Yeah, thank you again for coming along. Now we're looking at deriving quadratic equations from roots. How can we do that? We know that the general quadratic equation is ax squared plus bx plus c equals to 0, right? Now, when we solve this quadratic equation, it's values of x that we need. Most of the time, our x can be equals to probably 1 or x is equals to 2, right? So how can we, let's say we're only given these roots, these are the roots, how can we from these roots derive this quadratic equation? Good. Now, let's take our x. Let alpha and beta or beta be roots of a quadratic equation. So if alpha and beta are the root of a quadratic equation, what are the things that we can do? How can we from there, if alpha and beta are the roots, like when we have roots to be probably 1 and 2, what would we do if roots are 1 and 2? Then we say x is equals to 1 or x is equals to 2, right? Then we bring this here, we bring this here, equal to 0, then we are fine. So let's do the same thing. I want us to derive a kind of general method with the use of alpha and beta. So when we have a root of a quadratic equation, you can easily generate that equation. So we have it. So that means this implies that x can be equal to alpha or our x can be equal to our beta. Right? Now, let's bring alpha to the left hand side. That implies that x minus alpha can be equal to and this x minus beta can be equal to 0, right? Let's expand this. Expanding this, we have what? I wrote alpha is x minus beta. So x squared minus x beta. What again? Minus x what? Alpha. Then this times this plus alpha beta is equal to 0. So we have x squared. Something is common. This times this time this will be x beta. Don't mind me. Okay, x beta. So we have this. So what do we have next? We have minus. So we have alpha, beta, something is common, x, right? Then we have, this is minus. So what do we have there? Yes, from this place, something we can do is this. Yes, so we have, this will be plus. I mean negative. I factor the negative sign out. So I have alpha, beta, alpha this. So if I put my x here, I just factorize. Let me show you again, please. Let me show you again. So x times x squared, x times alpha, and x times x squared minus x times this x beta. Then this times this, that's minus x alpha. This times I have plus alpha beta, right? Now I have x squared minus x alpha beta minus x alpha minus x alpha minus x beta. X is common. Negative sign is equally common. Minus x open bracket. What do I have? I can have alpha plus beta or beta plus alpha. If I expand this, I will get this back. The arrangement is immaterial, right? So I have plus alpha beta. So what am I doing now? This is the same thing. The general formula is x squared minus alpha plus beta, x here, then I have plus alpha beta. This, don't forget, is equal to 0, is equal to 0, is equal to 0. So this is the general formula that we use. Are you getting it? So from here, we can use it. This implies that this is the sum of the root, because alpha, don't forget, let alpha and beta be roots. So that means sum of roots. And this alpha plus beta is sum of roots. When you add them together, while this is product of roots. Can you see that? Very good. So can you see that? So that implies that this alpha plus beta is sum of roots. Alpha beta is also, let's see, also considering the general a squared plus bx plus c is equal to 0. The general equation of what? A quadratic, or the general form of a quadratic equation, considering this, we want to also get sum and product from there. What do we do? Divide it through 2 by a. I want us to generate something. We're going to be having ax squared plus bx plus c is equal to 0 divided by a. We want to make the coefficient of x squared to the 1. So we have this a, this cancel this. So we have x squared plus b over a x, then plus what? C over a is equal to 0 by a is 0. Right? Very good. So what happens from here? We can now look at this. Don't forget our factorization process. When we do for product and sum, what our product always like? The constant term times the coefficient of this x squared, right? That is our product is c over a. Then we can take this b over a to the sum, right? That implies that b over a is equal to what? What is our sum here? Minus alpha beta. We only need this. Let's read this. We need the coefficient of x, right? So this is x. By comparison, let me call this star. By comparison with star, if we compare this with this, it implies that my b over a is equal to this, and that is minus alpha plus beta, right? And that also implies that this negative sign can come here. Any other can carry negative sign. So if you have come here, we have minus b over a to be equal to alpha plus beta, right? Then our products, by comparing with alpha beta, what do we have? It equally implies that c over a is equal to what? Our products, and that is alpha beta. So whenever we want to solve any question, all we need to do is just put, if you are given the root of the quadratic equation, and they tell us to generate the quadratic equation itself, we have been given the roots, which are what? Alpha and beta. Once we sum the two roots together, put them here. Once you take the product of the two of them, put them here. Then x squared minus whatever the sum is, times x plus alpha beta is equal to 0. That gives us the quadratic equation right there. In the next video, we have examples of this. I understand. Thank you very much.